Hello, everybody, and thank you for attending my talk. I'm super excited to be talking in Code Blue. We're going to look at what happened in Snowflake, the Snowflake campaign a few months ago, and we'll use that as something to look when talking about cloud detections. Let me start with a little bit about myself. So my name is Roei Sherman. I'm the field CTO for Mitiga. Before that, I was the global director for offensive services with Anheuser-Busch InBev. I have a bachelor's degree in information security and cybersecurity, and my master's degree is with criminology. For many years, I've been a part of the information security community. I'm part of the organizing team for B-Sides Tel Aviv, a volunteering judge with Trace Labs, a DEF CON goon for the last 2 years, and as part of my hobbies, I enjoy making my own beer. So the Snowflake campaign, most of you are probably familiar with it. We'll go over it in a bit of a high level of what happened, what it means. We had a threat actor named UNC 5537, which isn't a state-sponsored group, so they are not very resourceful, but they were still very successful. They managed to breach over 165 organizations worldwide, only through their Snowflake instance. The time frame for the entire attack was a few months, and they didn't use any vulnerability. No 0 days, no specialized tools, anything like that. And some of their big victims were Santander Bank and also the Ticketmaster group. If we look at the attack chain they had, so from the resource development portion, they had their own tools for being more efficient and automating the initial access, the exfiltration of data. They used a way built in Snowflake to identify their victims' instances. They had a staging place for all the data they managed to exfiltrate, and they managed to identify some configuration gaps within Snowflake to be used. As for their initial access, they used credentials they got from information stealers, not even phishing or anything like that. They used the native Snowflake tool to identify the instances to connect to, and then they just logged in. They used accounts that didn't have MFA enforced to get into the instance. Once they were inside the Snowflake instance, they exfiltrated the data within it outside of the organization to be used and sold for profit. And then in the end of the day, it's either extortion for companies they notified about the breach to get them to pay them, or selling that data online. Let's talk about what were the actual issues that they used in order to get in. So first of all, Snowflake is a data lake. It holds a lot of information, very important information. And companies use that as a SaaS offering. Even if it's self-hosted, it's still hosted within the cloud. The entire access was identity-based access. No 0 day, no exploit, no buffer overflows, nothing like that. They simply logged in. And once they got those credentials, it was very easy and very cheap. Information stealers' logs cost no more than $50 if they are super, super effective. But in a lot of cases, they go through multiple stages of sale, meaning a threat actor can buy them, utilize whatever they want, resell them to someone else, they use them for whatever they like, and it's very, very easy to get them. You don't need any highly technical skills, you just need to be in the right place and have the right amount of money. And then, using the lack of basic hygiene of no MFA, only putting a username and a password, clicking login, and they managed to get in. The way that allowed them to be able to do that was the way Snowflake configuration were shaped. So it's not a fault within the application itself or the product. It's not something they overlooked. It's just the way products were configured by clients. Then, so Snowflake, when they heard about it, they brought in Mandiant as their IR provider because they weren't sure if the problem is within the company, within the product, or something else. In addition, we looked at it also when we heard about it from a third party, and we started gathering information. In the end of the day, because there wasn't any specific vulnerability or a specific tool being used, nobody could provide any hashes or any patches. But we, Snowflake and Mandiant, were able to provide queries to clients they can use to detect if they were compromised. Using native Snowflake queries to identify if somebody accessed information, maybe try to exfiltrate it or move it to somewhere else, or doing anything like that. And the main takeaway from this entire talk is that when we talk about cloud and SaaS, our threat actors aren't breaking in anymore. They just log in. Because when we talk about on-prem, threat actors or any type of an attacker needed to land within your network. So either a phishing, an implant, a vulnerability, a 0-day, an exploit. But when we talk about cloud and SaaS, everything they need is a working set of credentials. And within cloud, we have a lot of different types of credentials. We have our, of course, employee username and a password. Some of them have MFA that can be bypassed because most organizations didn't implement it yet, phishing-resistant MFA. Also, think of all of your API keys, tokens, service accounts. All of those things can't have an MFA. And sometimes they are saved in clear text within code repositories. Sometimes they are being identified through different techniques. And usually, they have much more permissions than they actually need. So we mentioned SaaS and cloud in separate instances. However, SaaS is part of our cloud. It's a service that we buy from a company. It's something that we use. It's not something that we actually truly manage. We don't have the servers. We don't have access to the backend, or anything that happens in there is very limited to us. It's sort of a black box. And we depend on what the provider gives us. So we pay for the service, and they are responsible for their own security. But just like with Snowflake, if I configured something to be without MFA enforcement, do I blame my SaaS provider? Do I blame myself? Does every SaaS provider allows me to configure an MFA in a trusted way? With a Snowflake campaign, we saw that there was an option to activate MFA in Snowflake, but there wasn't an option to enforce it. And everybody's moving to the cloud. That's old news. Everybody here probably knows that the farther we go down the path, we have more cloud stuff. More organizations are shifting into the cloud, leaning more into SaaS. Organizations move to having between 5 to 10 SaaS to have over 30 in only the last few years. Spending is constantly increasing. The market for cloud and SaaS is huge. Most new startups offer their solutions as a SaaS-based solution and not an on-prem. On-prem became as a legacy option that you only offer for specific clients. And there are good reasons to move to the cloud, don't get me wrong. I don't think a cloud is bad or more dangerous or something we shouldn't do. But the main reasons, excuse me, companies go to the cloud, first of all, cost. It's much cheaper to transition to the cloud once you finish transitioning. You have less requirement to spend on maintenance, on hardware fees, on personnel. Maintenance is even easier because you don't need to send somebody to a remote data center if you need to swap out a bad power unit or a network went down. You get a lot of very good benefits with digital transformation. It's very easy and fast to scale up. So if you have a website that sells something, and now it's Black Friday, and you get a lot of people coming in, very easy to scale up, serve everybody, provide them with a very good experience, and when everything dies down, you can scale down and save the cost. Availability is big. We are a global world now. Everybody comes from different countries, from different places, and they want the best experience. We want pages to load fast. Companies want their advertisement to load effectively when people are reading articles. When doing it in the cloud, it's very easy to spin up resources in a very new region. And if your cloud provider doesn't support that region, there is a different cloud provider that supports that region. And as we mentioned about scalability, we can scale worldwide. If now I'm working with AWS in a specific region, I can also have something in Azure as a backup, or DR solution. There are a lot of big cloud service providers, a lot of small ones. But the main takeaway from this specific slide is what's not in it. You don't see security as part of those top 5 reasons. So organizations are moving to the cloud from a lot of different reasons, where security might be one of them, but it's not on the top of the list. And that's exactly what we need to change right now. Because breaches are moving to the cloud. As we saw in the last few years, and that's from the IBM cost of data breach report, that we have an exponential growth in attacks against cloud. And that's a very vague statement, because if a company is in the cloud and it was compromised, do we count that as a cloud breach because they are there? Or if somebody only attacks a cloud-specific resources, we count that. In the end of the day, if you ask a security operation team, it doesn't matter. They need to protect the organization, they need to protect the company, and if the resources are on-prem or in the cloud, for them, that's the company resources. And a lot of threat actors either start from the cloud and manage to find their way into the on-prem, or start from the on-prem and manage to get their way into the cloud, where now, as part of that transformation, all the sensitive, confidential, and quote-unquote juicy stuff is stored. And for the attacker, that's what they are after. Attackers are looking for the path of least resistance to make the least amount of effort for the biggest amount of value. And we'll take another example, what happened with Midnight Blizzard. I think it was a year ago. Midnight Blizzard is a nation-state actor. Means they have a lot of resources, they have a lot of time, a lot of headcount, they have latest tools, they have very unique and effective 0 days. None of them were used. They were targeting Microsoft, which is one of the biggest companies with the best security in the world, that runs one of the biggest cloud service providers, and they were still breached. In this attack, the threat actor used a password spray, and they managed to get into a legacy tenant owned by Microsoft in Azure. A password spraying attack is something that every pen tester in their first year in the industry does. It means to take a list of accounts of usernames or emails and a list of passwords and just running it and seeing what happens. When something succeeds, you manage to get in. In this tenant, MFA was also not enforced, so they managed to get into there. They managed to take over a legacy OAuth application with this tenant, and then using Azure native actions to take over additional parts of the network, do a lateral movement into the production corporate tenant for Microsoft in Azure, take over that, and got to a permission level that provided them full access to all Microsoft executives' mailboxes. Think of your executive mailboxes being fully available to a threat actor. That's one of the worst case scenarios for every company. And the thing is that even though they were a government-backed threat actor, they haven't used anything fancy. No 0 days, no specialized tools. They didn't spend years doing this attack. They used techniques that every pen tester and a red teamer uses in their engagements, and they managed to breach one of the biggest, most secure companies that runs one of the biggest clouds. The entire attack spanned over a few months before it was even detected by Microsoft. And that's exactly the thing. That's a cloud-only attack. No phishing, no on-prem involvement, no malware, no C2s, no communication. They managed to get in using native cloud actions. Everything that an admin can do or a user can do, that's what they did, and that's how they got in. And I'm not blaming Microsoft, to be honest. Detection in general is hard. Detection in cloud and SaaS is even harder, and that's exactly what we're going to talk about. When we protect our on-prem, we have a lot of different tools. We have DDR, we have network logs, we have IDS, IPS, we have NAC, a lot of different technologies we can employ. But also for defenders, for the blue team, we have very clear processes. We have open source software. We have IOCs. We have hashes. We have ways to query. We can isolate devices that were infected. It's not easy to protect an on-prem. It's just easier than the cloud because we have the tools, we have the processes, we have the skills. When we go for the cloud, we need something better. The first one should be context-aware. And what I mean by that is, as we mentioned, if the attacker does actions that are native to the cloud and are the same actions an admin can do, how can we differentiate when admin does the action or a threat actor does the action? We need a context. Behavioral and anomaly-based. It means it's true that an admin can do it, but how frequently they do it? Where are they coming from when they're doing it? Where they're connecting from? Do they do the same thing over and over again? Or is it a very unique and odd activity to be carried out without being communicated and approved internally in the company? So first of all, we need a baseline. And within cloud, do we have that baseline of what usually happens and where and by whom? The logic has to be generic because we tried UEBA a few years ago, all of us as in industry, and most of what it did was create a lot of false positive alerts. And that's one of the most hated things for security team, to have false alerts. It takes away your attention, takes away your focus. It creates burnout when you need to go through 5,000 alerts that none of them make sense. And because we have different providers, we need to find a way to apply that logic across the board. Because if we build something that works very well on AWS, but we are a multi-cloud company, we can't use it for Azure. And tomorrow we're going to use different clouds, and we need to apply the same type of logic also for those different clouds. So we have a few problems we need to tackle. The first problem would be the the visibility. In cloud service providers, logs are turned off by default. And some of you are probably thinking, no, wait, I have CloudTrail. All right, and what about the rest of the logs? In each cloud service provider, we have the main log, but we have a lot of other effective supportive logs, and they're turned off by default. The reason for that is because they cost money. And the cloud service providers, as part of the shared responsibility model, they say, if you want to protect your environment, pay us, we'll give you the logs, we'll give you whatever you want, but you need to do whatever you want with it. We are protecting the infrastructure, we are protecting ourselves, but our customers are responsible to protect themselves. Also, when you turn on the logs, and that's a very common pitfall, you need to turn it on everywhere. And it's not automatic, it's not easy, it's not straightforward, even through the UI they offer, because clouds are made for productivity, for the business. They are not made for security. Security is something that we add on top of those services. And then in the end, as we mentioned, you have the log types, and a lot of companies that I meet say, yeah, we turned on S3 bucket logs, so we can see the access. And then I usually ask, and what about object level logs to see who touched which file and when? And they look at me and say, we didn't know this log type existed. And that's the thing, you might have a log, but do you have the right content within those logs to be used by your security team later on? In SaaS, the problem is even bigger, much bigger, because not all of them even have security logs. Some of them offer you access logs. Those are not audit logs. Those are not security logs. What's their content? Are they turned on? How far back do they keep them? Because you might have an incident now that started a month ago, 3 months ago, or 6 months ago, and if they don't have that retention, you're stuck. The license tier is another barrier. For example, Slack only offers security logs for enterprise-level licensing, not all the companies that use Slack need an enterprise-level licensing. So when you get a SaaS on board to your company, make sure you check the license tier for security logs. And then in the end, security logs and application logs. A lot of SaaS platforms will give you application logs so you can see when somebody got in, but do you see where they got in from, which actions they took? And in order to solve those problems, we need to talk with the DevOps. The DevOps are not security people. They are DevOps people. And our security operations are not DevOps. And that's one of the problems we have, because security team will tell the DevOps, I need you to activate S3 bucket logs. The DevOps will go, they click the buttons they need, but they don't know which logs to turn on. They don't know if you need to turn it on everywhere. They don't know which accounts makes more sense to you or more important to you, because they look at the business and the productivity, and SecOps look at the security of the organization. And we need to let them know that we need this, this, and this activated, and that's how you do it. This is where we need it activated. That's the retention time. That's how we are going to consume it. So if there are different ways for an output for a log, we need to let them know what we need. And then to verify it, because they might did everything we asked for. Maybe we didn't ask for anything. Maybe there was a lost in translation there. But now it's time for us to verify. Can I see the activities I was looking for? Can I build the detections I'm interested in? In SaaS, it's very hard, because if a SaaS platform tries to sell you something, they'll say yes to every question, and everything you ask if they have it, they'll say, we do. But then you need to simulate some red teams. Then you need to bring in somebody to try and do something on those SaaS platforms that you are worried about, and see if you can actually see that within your logs, let alone the detection. But think of Disney, that somebody managed to get access to one of their employees and managed to exfiltrate over 1.6 terabytes of Slack messages. Some of them contained additional access keys, some of them contained username and passwords and a lot of different types of confidential information. Can your SOC or SecOps team can even see that in the logs when they'll try to investigate? And then look at your contracts. Do you get the logs you need as part of buying that solution? And it's a very, very normal request from a vendor to provide you the means to defend yourself using their solution. And then in the end, application logs are usually useful for the application teams. The security logs are efficient for the SecOps team. And some of the providers might tell you, yeah, we have the logs. You go to this button, and if you want to see them, you need to export them manually. Can your SecOps team handle that? Can they build the automation for it? Or you need something more streamlined and making sure it's effective for your team? The second problem that we have is identity over malware. So it's a very known cliche that identity is the new perimeter. In on-prem, you needed to breach the perimeter. You needed to get through the network. You needed to land inside in order to do something, whether through physical access to the network, maybe getting in through a VPN, sending a phishing email. In cloud and SaaS, the identity is the perimeter. As we mentioned, you get a working set of credentials, you're inside. SSO is the king. And we can't have hashes for behavior. So as we mentioned, in Midnight Blizzard, when somebody changes an application permissions, it's not something that we can use as a hash, because that's part of how the system works and how the functionality is. Information stealers are very cheap and easy to use. In the past, in order to build an exploit, or still now, to find a zero-day and build an exploit for it, you need to be very technical. You need to know what you're doing. You need to know how to reverse engineer. You need to know how to write code. Even if you use ChatGPT, you still need to know what you're doing. Buying logs only asks for internet connection and a working credit card, either stolen or not. And for the perimeter, we already discussed it. So the first thing is the basic hygiene. Everybody says it, still not all organizations implemented it, MFA. However, we need to think on what we do with the entities that can't have MFA enforced. API keys, service accounts, what do we do about those? We can't have a hash for a behavior, but we can get characteristics. It means that we know how people usually do their jobs. Usually what is being carried out on a daily basis, a weekly basis, a monthly basis. We can have sort of a baseline to compare against. And proactive threat intelligence is something that can help us identify if something that belongs to us, like credentials or API keys, are being exposed. It helps us to be proactively defensible, meaning if I know it's out there, I can already look where it's coming from. I can rotate credentials. I can disable an account. A lot of different stuff that I can do to stay left of bang. Additional thing is automation. One of the things that look at informations from threat intelligence information is that, all right, if this is exposed, I can verify it automatically if it's work or valid credentials, and if it is, block it and rotate it automatically. It can slow down the business a bit, but it still save us from a very big incident. And then about the perimeter, all right, so somebody got through. Somebody managed to go through our identity provider. What are the other steps they're doing? So if they got through Okta, and now they got into our HR SaaS solution, is it something they're usually doing? And that helps us against the baseline we mentioned to see if something makes sense or not. Because think of your CFO, most of them probably never go to your cloud provider, whether AWS or Azure. They don't deploy EC2s or write Lambdas. But then if they go through the identity and then go to the cloud provider, that's weird, right? That's something suspicious. So the follow-up events helps us understand when something is weird or suspicious. And the skill set. So the skill set is a very, I would say, everlasting discussion in the industry, because skills keep changing, technology keeps changing, and we always need to build the skills after we have the technology. We don't train people for cloud and then transition to cloud in the majority of cases. And when you talk about SaaS or cloud, everything has a UI. Everything is API-based. Documentation is everywhere. If I want to figure out how to write a Python code to empty an S3 bucket, I don't need ChatGPT. I can just go to the documentation in AWS. They'll give me everything. They'll give me the SDK. Every major cloud service provider has their own CLI solution that I can use as part of my automation, and that's what companies do. That's what, companies do for their automation. So it's something hard for us to track because everything is very, very easy. And investigating a bucket leak is something weird for SecOps, because in on-prem, when somebody gets into a database or a file server, we know how to investigate it. We can see the file system, we can see traffic. In a bucket, we only depend on the logs. We can't install an EDR on a bucket or a Lambda or anything that's not a workload. And the SaaS platform are entirely black box for us. Somebody got into the HR platform and changed salaries. How should your SecOps investigate it? Or you're trusting your SaaS provider, which is not a security company and maybe doesn't have a security people in it, to investigate it for you. And then, again, the EDR, all the tools, the NAC, the EDR, the stuff we have, can't be used across the clouds. We have a lot of functionality, a lot of types of resources that we can't actively monitor outside of the logs. And it makes it very hard because EDR is not only for monitoring, it helps us with active response. So you want to isolate something, you want to take something out, you want to take a snapshot of its memory, you want to see what happened. You can't do that on a Lambda or a bucket or a storage account or any of those things that are not a pure workload. So the first thing we need to do, which is pretty straightforward, is training our own people. Attackers are training all the time. I did 10 years in offensive security, and we had at least 20 to 30% of our time, and we are not threat actors, just training, going through free courses providers are offering specifically in the cloud, doing dedicated administrative training and not even offensive training, because the difference is very, very little. Hands-on drills to train your people on how to do stuff they never did before. Get somebody to download files from a bucket, don't tell them when and where, and let them investigate it. They'll identify gaps for you. They'll say, yeah, I'm missing this type of telemetry. I don't know how to do that. We need help, and that's when you know how to handle that. Threat hunts are super effective, because once you get the logs, you don't know what happened before, but then they can build the hypothesis of, all right, HR system is used for salaries. Did somebody change those? That somebody is from HR or from a different group. And full monitoring is all the logs, all the time, near real time. There is a gap between when something happens and until the cloud generates those logs. So it's never really real time like we're used to, but it's still better to know that somebody did something an hour ago instead of knowing they did something a month ago. And our roles and responsibilities. That's a very big problem for every organization I've met. Who owns the security for cloud and SaaS? Think about it for a second. Some of you will think of SecOps. Some of you will think of SecDevOps. Some of you will think of DevSecOps or DevOps or cloud security team. The thing is that we have so many answers means that we don't have one standard. And that makes it very hard. Who enables logs? Security team knows which logs they need, but do they have the permission to go and touch production environment in cloud? Should they? Who is using the logs? It's the SecOps, but they're not managing the platform, so do they have it? And who ends up investigating? Can somebody from the SecOps team can touch every resource on the cloud? Do they have the permission to do so? Are they allowed by the organization policy to do so, to look in confidential data, maybe customer data? And when you need to mitigate something, who does it? Because we have a lot of very, very good CSPMs in the market, and they surface a lot of problems. And that's exactly the thing. CSPMs are meant for DevOps. They show you risks. They don't show you a threat. They show you a problem that might turn into a threat if somebody abuses it or exploits it. But in the end of the day, the people that need to fix it are the DevOps people. They need to change the policy. They need to remove something from being exposed to public. They need to patch a system, not your security team. So the first thing is to have a very clear definition. Have the meeting inside your organization with the DevOps, with the SecOps, with the cloud security, with the CISO, and determine who does what. We have SOPs for everything. We have playbooks for IR. And now when something happens, do they get the access they need to? And then they should get that access. Companies give their SecOps team almost unlimited access to the on-prem, but they don't give it in the cloud. And I heard a lot of different reasons. All of them make sense because they're afraid they're going to hurt production. They're afraid they're going to hurt the business. They might make a decision the business is not happy with. But if you're trusting them with on-prem, why aren't we trusting them with our cloud? Does your security people don't care about the business? And then in the end, a tabletop. A good tabletop runs through an entire scenario without even touching the keyboard once and asking them what they're going to do and getting examples. And it doesn't have to be from an executive level, but put the teams in the same room, tell them what happens, and see them argue. And see them saying, oh, wait, I can't do that because I don't have the access. And then the DevOps says, all right, so you need to tell me and I'll do that. But the incidents always happen on the weekend, during a holiday, at 3 a.m. That's how it is. And DevOps doesn't work like an IR. I hope they'll never have to, but that's part of the things we need to consider. And a very easy way to do that, take real case scenarios. Take Midnight Blizzard, go through the entire process, and how would that being handled, detected, and mitigated in your organization? Take a look at the Snowflake example. Take a look at the Sisense breach that happened not very long ago, where somebody got into their code repository service, GitLab, managed to steal an API key, and used that to siphon data outside of an S3 bucket. And then the last but not least, false positives. Every time you talk about a detection, the first question you get from security people is, what's your false positive rate? And we are now in the age of work from anywhere. People are working either from their home, hotels, they keep traveling. Everybody has their own location. Companies are still global, thank God. And we have a lot of SaaS. So SaaS is hosted in a lot of different places. We don't control where our vendors host it. And actions, when you go for the cloud, are not malicious. Only the intention is. When I download a bucket, or a threat actor downloads a bucket, we're doing the same action. Our intentions are very different. So first of all, we need to look at how common are new things. When somebody goes to a new platform, somebody goes to a new region in the cloud, somebody runs something new, how common is it? Because usually we don't deploy in a new region every day. That's something that's planned before and happens once in a while. Flow detection against or compared to atomic detections. Atomic detection is when something specific happened, that's an alert. I don't like it. And no security operation team likes it. But when you have a flow, when you can say, in here we had unusual login because it's from a new country to our IDP, and then access to Snowflake, which they never accessed before, and then they ran queries for 2 hours. That's a flow of an attack. That's something SecOps is interested in, and it's much more effective. And Snowflake is not the problem here. Like Microsoft is not the problem. It's just as an example for a lot of breaches we're going to see in the upcoming years, because attackers look for the easiest stuff they can do for the most value they can get out of it. And SaaS and cloud are very, very easy for an attacker. So it will happen again, and we have to look at the concepts that we mentioned, and not only tools. Tools will change. So just as an example, when we talk about that type of detection engineering that we mentioned, I want to run you through sort of how it builds, because you have a lot of different moving parts that all of them combined into a specific thing. First of all, we'll have the threat intelligence saying something that belongs to you is out there, somebody can buy it, somebody can use it. Then you compare it with, all right, do I have exposed resources? Where they are? Do they have vulnerabilities? When somebody comes in, which country they're originating from, which IP, which user agent, is it something that's common for them or not? What type of activity they do, and which platform they're going to and who they are. So if a CEO falls for phishing or a developer, it has entirely different impact. All of those things are combined to determine both the confidence in this alert, on how well we are certain that's malicious, but also the severity. How bad is this thing when it happens? And then taking the example of what happened with Snowflake on something that we did, for example. First of all, threat intel integration. We know in this case the IPs or the VPN they use, so we have a very long list of IPs. We see a rare IP coming through our identity provider, and we match that against the threat intelligence. Then we also compare how many times they try to log in through those IPs. So if we see a spike in attempts, something weird is going on, because even if somebody forgot their password, they're not going to try 50 times in less than 2 minutes. And then we see them accessing the Snowflake, but then they go for different warehouses. And we can compare each identity from the logs, which warehouse inside Snowflake they're usually connecting to. And are they going to the same one, or they are trying all of them or something new? And then we look, it's a specific log source by Snowflake that says query history, which queries they ran. Are there part of the query is moving data somewhere, maybe outside of the organization? And when we see them, in one of our client environments, moving data to GCP, where the entire environment is in AWS. So we know we have an incident. So just to wrap up, few things you can take and start doing. So the first thing for next week, we talked about the visibility. It's not easy, it's not cheap, but it's something you have to do. You have to have for your security. Make sure you get all the logs you need from your cloud service providers. Reach out to all your SaaS platforms and make sure you get the right logs. Next month, start planning your behavioral detection strategy. How your organization looks like, how it operates, what you need in order to determine that, and build the roles and responsibilities between your different cloud teams, and spend time starting with upskilling them for threat hunting. And then the baselining, that's the longest part, that's the hardest part, where you need to find a way to build a baseline of activities within your organization for cloud and SaaS to be able to build the detections we just discussed, and then work on anomaly detection. It can be used in your existing tools, open source tools, whatever way, shape, or form your SecOps like it, it's something that you can do. And last, domo arigato gozaimasu.